Boom. So then, Bosco, you turn all these into fractions, and now we're going to order them from least to greatest. So which is easier to do now. So the smallest number there is what?
It's the smallest is negative. No, -1.
Negative 1. Okay. And then the next smallest one is?
Negative 0.4.
So negative 0.4. But then I want you to give them to me as the numbers they were to start with. We're using the decimals to compare. But when you actually list them, we're going to go from negative 0.4, and we're going to give me negative 2/5. So you've done the conversion to make it easy for you. But now we're going to actually use the value we started with. So then the next smallest one is 4/9.
And then 1/2.
And then a half. Because, yeah. Reasons.
And then 1 2/3.
And then 1 2/3. And then 2. Cool. And now you can go, I mean, some of you may not have done that first. Some of you may have done the number line first, and that's fine. When you are quoting me an answer for these questions, I want you to make sure you actually use the values that I gave you to start with, even though you may have converted them to make your life easier. So now we want to go ahead and place these numbers on a number line. That is an unlabeled number line. So how are you going to go ahead and do that? Anybody? William?
Put 1 on the left side.
You want me to put 1 on the left side?
And 2 on the right.
You want me to put 1 and 2?
0.
You want me to put 0 and 2? Are you sure?
Oh, negative.
There's negative values.
Negative 1.
Okay, you meant negative 1. For a question like the, do we want to start negative 1? If we do that, hold on. Okay. We do want to be, yeah, you could, but because there's tick marks here already, we want to be careful with some, like we can scale this thing properly. You could do that, but then you want to make sure, if you're going to place negative, okay, so if you want to put negative, is there nothing smaller than negative 1? No. Okay, so you're going to put negative 1 there. So I would use that as your reference and then build your scale away from negative 1. How do you want to make your scale, William, if you're going to put negative 1 there? Are you just going to go negative 1, 0, 1, 2 and call that good? Or do you want to have more space between your whole numbers to give you some space to work with? Okay, so then how much space do you want to put between negative 1 and the next integer, which would be 0? Do you want to go up by quarters? Do you want to go up by tenths? What do you want to do? Fifths? It's up to you. Tenths. If we go up by tenths, that means there's going to be 10 tick marks to take us to 0, which would be negative 0.9, 0.8, 0.7, 0.6, 0.5, 0.4, 0.3, 0.2, 0.1, 0. If we went the other way, that would only take us to 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7, 0.8, 0.9, 1. So we'd be short these two values. So going up by tenths wouldn't work on this particular number line. You went up by fifths? You could go up by fifths, because if going up by tenths would take us to here, going up by fifths would take us further, for sure. You could go up by fifths. If you went up by fifths, you would have, that would be negative 0.8, negative 0.6, negative 0.4, negative 0.2. This would be 0 then. That would be 0.2, 0.4, 0.6, 0.8, 1. 0.2, 0.4, 0.6, 0.82. You could do that, sure. You could have also gone up by halves. If you'd wanted to do that, you could have done that instead. Halves, I don't think I have. Oh, I do have. If I use this number line, halves would look similar. You start down here at negative 1. You'd have negative 0.5, 0, 0.5, 1, 1.52. You're still not using a ton of the number line, but it would fit. Like, you could do that as well. How you choose to scale the number line doesn't matter as long as you cover the entire spread. Questions, comments, concerns about that? Okay, so then let's go ahead and place these things. I feel like I'm missing pens. Nope, there they are. Okay, so then negative 1's already there. Love it. Negative 1. Are we choking over there? Are we good, Dea? We're not dying? Okay, cool. Negative 2/5 would be where? Well, negative 2/5, Bosco converted to negative 0.4 before. That number is right here. Love that. Negative 0.4. Yeah, Dave, if you're dying, drink some water. Which would be negative 2/5. Love that. Okay. Where would 4/9 be, Dea?
4/9?
4/9.
Sorry. So 4/9?
Yeah.
That would be about, I think, 2. What it'd be. So after 0, it'd be 2.
So that would be 0.2. That would be 0.4. That would be 0.5. So where would 4/9 be?
So it'd be 2 actually, right? Or would it be 1 actually?
Well, Bosco said that 4/9 was 0.4 repeating. So where would I put that on here?
0.04.
After the 0.04. But less than halfway. Because halfway between 0.4 and 0.5 would be 0.45. So that would be my 4/9 right there. Yep, you betcha. And then my half is 0.5. That's right there. What's my next one? 1 2/3 was 1.6 repeating. So this one would be, based on the scale that we were given, this would be 1.2, 1.4, 1.6, 1.8. So where would 1 2/3 be on that number line? Eve, you look like someone with an answer. Do you know? You look like someone who knows where 1 2/3 would be on that number line. 1 2/3. This value right here. If you'd like to phone a friend, William's got his hand up. Well, if you've got 1.2, 1.4, 1.6, 1.8, where in here? Remember, so then Bosco did it before. 1 2/3 is 1.6 repeating. So 1.66666. Where's that going to be on this number line? Yes. Closer to the 1.6. You betcha. So that's going to be your 1 2/3. And then your last value is 2. So that is the placement of those numbers on the number line. Very good. You didn't have to do it that way. Someone in the other class decided to use integers, and so they crammed everything into there, but that's technically correct. They said 0 is right in the middle, so that's -1, and that's 1, 2. And they slid things in there. That works as well. It looks gross, but it works. Did anyone have a different way of doing things that they want to demonstrate? That, okay. Or that they want to ask about. That was, where did my lid go? Come here, you. Seriously? I'll get you later. Okay, so we almost made it through the lesson yesterday. We were so close to being done, but as, you know, pretty standard, I had one more thing that we needed to finish. Before we do this, this will be the end of, I would like everyone to gaze at the TV. You should always be all gazing at the TV. But especially those of you who are working ahead and on your phone, I want you to take a breather for a sec. Put your phones away. And take a gander at the television. All of you always looking at the television. Lesson 1, order of operations is done. Lesson 2, fractions review is done. Lesson 3, comparing numbers will be done today. We will be done. Lesson 3 today, very shortly. So, I'm not going to say that there's a quiz tomorrow, but the schedule seems to imply that that's what would come next. So, I would like you to use your powers of deduction to make an assumption about what I might inflict upon y'all tomorrow. This is the only time I will be this explicit. And I'm not even saying that there's a quiz tomorrow. But I'm doing everything but say that. From here on out, it'll be your guys' job to pay attention to what's coming and prepare accordingly. So, I'll even underline this without even saying that that's happening. Anyone who's ever had me for a long time, Iniad, can vouch for this. This is the most notice you will ever get for a quiz. I almost never give notice for quizzes. Okay, here we go. Let's finish this up, shall we? Converting decimal numbers to fractions. This is not an overly difficult conclusion to the lesson, but I wanted to give you some time to work on stuff yesterday, so here we go. Converting decimal numbers to fractions. If you recall, or if you think back, how do I read this number? If you're going to use English words to read that number, what are you going to say?
1.234. No, 2000. No.
Hold on. 1 point. Keep going with the first thing you were saying. Stop cutting yourself off.
340.
No, don't do it that way. That's not how normal people would say it. 1 point to, because I'm not trying to, I am going to frame it the way a mathy person would say it, but I want you to start with the way colloquially you guys would usually say this. We would say 1.2 3 4 5. Like, and that's normal people, that's what it would be it. 1.2 3 4 5. And that's enough to picture 1 decimal 2 3 4 5 and you're done. That is generally how people would say this. And your elementary school teacher, your middle school teacher, wherever you are started playing with decimals, that's likely how they said it, unless you're, I mean, if you weren't learning it in English, then they said something entirely different. But generally speaking, we lose the proper language around decimal place pretty quickly for the sake of convenience. But what is the actual name of this number? You wouldn't say 1.2345 if we were trying to describe a fraction, which is what we're trying to do now. Dea.
1 and.
Okay, so 1 and. When you're reading a number and you say the word and, that is a decimal point. So if you had like this number, that is lots of people say 1,234.
Yeah.
1,234. And means decimal, so that wouldn't be 1,234. That would be 1,234. Nothing in between. Okay? So let's forget about that for a second. So the and implies the decimal. 1 and. Dea, continue.
2,300.
Hold on. 300. 45.
10,000.
10 thousandths. Very good. And this is not what normal people say. I don't even say this. And I wouldn't classify myself as a normal person. There aren't very many people out there with with master's degrees in mathematics. I mean, we exist, but there's not very many of us. I wouldn't classify myself as I don't even say this. But that's what this number is. You look at the places you're at. There's the 2 is in the tenths spot. The 3 is in the hundredths spot. This takes us all the way back to what we were doing on day 1. The 4 is in the thousandths. The 5 is in the thousandths, THS. This is in the 10 thousandths spot. And referencing the spot you're in actually tells you everything you need to know about putting this thing into a fraction. Because if I have that value, 1 and 2,345 10,000ths, what does that actually mean? It means you have one whole, and as Dea read, 2,345 10,000ths. If you can identify what place value you have, then making the fraction is done effectively. Because and I've given you the instructions here. When you're taking a decimal number and you're converting into a fraction for whatever reason, this is a rare thing to do. Most people don't like to convert into fractions. They like to take things out of fractions and put them into decimals because we have an easier way to conceptualize those numbers. But if I asked you, and I'm going to ask you today to convert these decimals into fractions, you want to find the decimal place of the last number that is not a 0. So in this case, it was a 5. The th place becomes your denominator. So the 10,000ths spot is where that 5 is. So that becomes our denominator. The actual decimal value, the 0.2345, that 2,345 becomes the numerator. The whole number becomes the whole. You could turn this, if you wanted to, into a mixed number. We don't want to do that. Oh, sorry, into an improper fraction, but we don't want to do that yet. And then simplify if required. So this is the process that we did to get to this point. And now I can simplify that thing. What are 2,345 and 10,000 both divisible by?
5.
5. How do you know, Bosco?
Because it ends in 5 and the other one ends in 0.
Numbers that end in 5 and 0 are both divisible by 5. So you need to know some of your divisibility rules now. What's the divisibility rule for 2?
That it ends on a...
Dea.
So that if they're all even,
They're all even is the English word that we use. So if they're even, 2, 4, 6, 8, or 0, 2, 4, 6, 8, all even. What's the divisibility rule for 3?
When you add up every number in the whole number, it's a multiple of 3.
When you add up the digits and their value, what they add to is divisible by 3. So for example, 2 and 3 is 5, and 4 is 9, and 9 and 5 is 14. 14 is not divisible by 3, so this number is not divisible by 3. The sum of these digits is 1. So 10,000 is also not divisible by 3. What's the fourth divisibility rule? Does anyone know?
Is it the one that the 2 last
The last 2 digits are divisible by 4, then the whole number is divisible by 4. You betcha. So is 45 divisible by 4? No, it's not. So then 2,345 is also not divisible by 4. The divisibility rule for 6 is easier.
That is 2 and 3.
It's got to be divisible by 2 and 3. The divisibility rule for 7, I don't even want to think about.
You have to
Yeah, it's awful.
add and multiply.
Yeah, add and move. Let's not talk about 7. The divisibility rule for 8 needs to be divisible by 2 and 4. And then the divisibility rule for 9,
Same as 3, but it has to be
the same as 3, but it has to add to
a multiple of 9.
a multiple of 9. So 2 and 3 is 5, and 4 is 9, and 5 is 14. So this number is not divisible by 9. So let's divide both by 4 and 5. So divide them both by 5 is what I meant to say. Divide by 5, divide by 5. The denominator is easy. 10 divided by 5 is
2.
2. So 10,000 divided by 5 is 2,000. The numerator, what are you going to do for the numerator? You're not allowed a calculator. So if I made you do this by hand, you'd have to. Long division. Here we go. The 5 goes up front. The 2, 3, 4, 5 goes on the inside. 5 does not go into 2, but 5 goes into 23 4 times. 4 times 5 is 20. You do the subtraction. That's 34. 5 goes into 34 6 times. 6 times 5 is 30. 34 minus 30 is 4. Bring down the 5, and you're going to get a 9. 469. So then 1.2345 as a fully reduced fraction would be 1 and 4,069 2,000ths. Is how you'd read that, or over 2,000. So if I asked you to convert this number into a decimal, in this decimal number into a fraction, that is what you'd have to do, and this is what you'd get. Questions, comments, concerns on any of what I've just done? Okay. Hearing nothing, let's do some easier ones because that one was ridiculous, and I will not ask you to do things like that. So, 2.19, what's that going to be then as a fraction?
2,
The whole number is the whole number in the mix, you betcha.
and then divided by, would it be 3?
What place is the 9 in the 0.19? It's in the hundredths space. Why would I put a 3 there?
I meant, would it be divided by 3?
What are you trying to do, Dea?
Wait, okay, so it's
Okay, cool. So do that. So the 9 is in the hundredths spot, so we're going to put 100 down there. There's going to be a 19 in the numerator, and is that thing reducible?
No.
No, because 19 is prime. Done.
I forgot why we divided it.
So, I mean, if you wanted to, you could have made that an improper fraction as well. I had a student in the first or last block who's like, can I just leave them all improper? Yeah, you betcha. To make it improper now, we're just going to take the 100 multiplied by 2. 100 times 2 is... and then add it to the numerator. So if you wanted to leave it improper, this would be 219 over 100. I'll do a couple more examples and I'll leave you to your task. Let's do this. So point 2. Point 2 is going to be what? If we follow the steps, what's point 2 going to be as the first fraction we're going to convert it to? The 2 is in the tenths spot, so this is going to become 2 over 10. And now we can reduce. 2 and 10 are both divisible by someone other than Dea. 2. 2 divided by 2 is 1. 10 divided by 2 is 5. So, point 2 is 1/5. One of the things I asked you to memorize yesterday. The next one, letter B. The instructions do say... find the decimal place of the last number that's not a 0. So the decimal number that's not a 0 there is a 2, and the 2 is in one spot. The tenths. So it becomes the same question as the one that we did above. Let's pretend, and I know none of you do this, but let's pretend all of us don't remember the instructions. I know that none of you do this. All of you remember the instructions all of the time. But let's pretend you have forgotten the instructions, and let's see what happens. So if you've forgotten the instructions, what's the 0 in? In the thousandths. So that's going to become your denominator. And then the 200 is what you're going to put in the numerator. And now we can start simplifying these things. 200 and 1000 are both divisible by what? Oh, if you want to go that way, we can do it that way. That's a shame, but let's do it. There are easier ones to do, but if we want to divide them both by 2, we can. If they both end in 0, they're both divisible by? They both end in 0, they're divisible by 10.
And they both have 2 zeros. So
they both have 2 zeros, so they're both divisible by?
100.
100. Eve, are you sure you want to divide by 2? You want to divide by something bigger? 100? Yeah. Let's do that. Make our life a little bit easier. If it ends in 0, it's divisible by 10. If it ends in 2 zeros, it's 100. If it's 3 zeros, it's 1,000. We only have 2 zeros here. So this is going to become 2 over 10. You can just cross off the zeros there. Which we can divide now both of these by 2. And we're going to get 1 over 5. Oh, look, the same result. And it should be. Because 0.2 and 0.200 are the same number. Cool. What's 3.4 then going to be as a fraction? First step, someone other than Deo? Yep. 3 and 4 over 10. 2. Divide them both by 2, divide them both by 2, and you're going to get 3 and 2 over 5. Done. Love it. How about the next one? Someone else. The whole number is going to go out front. That 5 is in what spot? The hundredths spot. So this is going to become over 100. The 5 is in the numerator. And both of those numbers are divisible by 5. Divide by 5, divide by 5. The whole number stays out front. 5 divided by 5 is 1. 100 divided by 5 is? 10 divided by 5 would be? 10 divided by 5 would be? 2. So 100 divided by 5 is going to be? 20. So 2.05 is 2 and 1/20th as a fraction. And the last one, the whole number stays out front, and what's the fractional part going to be? 1 over 1,000. Because the 1 is in the, not the tenths, the hundredths, the thousandths spot, and 1 is not divisible by anything other than itself, so you're done. Okay, for those of you who have worked ahead, I am going to change the instructions on the homework that I gave. And so you're going to have to go back and make sure you're cool following the instructions for what remains. But now at this stage, I'm going to give you guys homework and tell you that, you might want to look at the schedule about what might be coming at you tomorrow. And then once you finish what I'm about to give you, use your time accordingly. So there are 4 questions here. All 4 questions have the same instructions. Compare the following numbers and order them from least to greatest. Additionally, I'm going to give you instructions about how I want you to do that, because those of you who worked ahead probably cranked everything out into decimals and called it a day. Just to force a little bit of practice here, I want questions 1 and 2 to be done by convert all non-integers into fractions with a common denominator. That is how I want you to do questions 1 and 2. That'll force some practice here. And then I want you to do question 3 by converting. Give me a sec, Sandos. You might want to write down these instructions. Because if you're going to ask to go to the washroom, I'm going to say no because I'm giving you instructions. Give me a second. Convert all to decimals, which means you might have some long division in your future because there's a fraction over 7 there. And I want you to do them all by hand. So that is your task. Once you are done, take a look at the schedule. If there's anything you want to review in the light of what is happening to you in the future, you're welcome to do that. If there are no questions, on your mark, it's set. Giver.
First, I want you to tell me which the homework, which